Hello, and welcome to a video introduction and illustration of IBM's WebSphere Application Server for z/OS Optimized Local Adapters, or WOLA for short. This video series is divided into 5 parts. The main topics covered are shown here. The Essentials of WOLA, in which we will provide the background for this function, as well as some key concepts important to understanding the details that will follow. How WOLA is implemented and used in CICS, how WOLA is implemented and used in IMS, the WOLA native APIs and how they are organized and used, and the Java-side coding considerations for using WOLA. There are 4 sources of information on WOLA we would like to bring to your attention. The TechDocs website, where IBM's Advanced Technical Skills Organization publishes technical material. The WP101490 TechDoc is the central repository for WOLA-related information. Currently published documents include an overview presentation, a concise planning reference guide, and a guided exercise primer on the coding and use of the native APIs. The IBM Info Center for WebSphere Application Server. It is the official home of the product documentation. Searching on the key string CDAT_OLA will produce the introductory article on the subject of WOLA. There is a Wikipedia article on WOLA you may find at the URL shown, or by searching on uppercase WOLA and then clicking on WebSphere Optimized Local Adapters on the disambiguation page. Finally, there are several YouTube video channels that contain content related to WOLA. The first is found by searching on WOS-OLA1. The second is found by searching on ATS Demos. This video series is found under the ATS Demos channel. The Essentials of WOLA. WOLA is based on a technical function that has been in the WOS product since the very early days. That technical function is known as local communications, or LocalComm for short. We will briefly explain what LocalComm is, then show how WOLA is in fact an externalization of this LocalComm function. We start the illustration by representing a z/OS logical partition, or LPAR, and we add to that 2 z/OS application servers. Each has its own area of storage used by the application servers. On WOS there is a server called the daemon. The daemon server owns a portion of storage above the 2 gig bar. Now imagine one application server has a servlet running, and that servlet wishes to send a message to an EJB in another server. Remember, the 2 application servers are on the same LPAR. That is important. LocalComm is limited to cross-memory communications within an LPAR. So too is WOLA. The message is formed and is held in the storage area for the servlet application server. Because WOS understands and exploits the z/OS platform on which it operates, it understands that the message is eligible for cross-memory transfer. So the daemon forms up a pointer to the storage location of the message. That pointer is passed to the target EJB, which uses the pointer to go into the storage of the servlet application server and copy the message to its own storage. This is entirely automatic and is completely transparent to the application. The TCP/IP function is never invoked. This transfer is handled with the z/OS cross-memory service. Because there is so little overhead associated with cross-memory transfer, it is a very fast and efficient way to exchange messages. But because it is based on a cross-memory transfer, it is limited to operation within an LPAR. This LocalComm function is one example of how WOS understands that it is running on z/OS and exploits the services of the platform. With the picture of LocalComm fresh in your mind, let's now show how WOLA is an externalization of LocalComm. We have the same 2 application servers as before, along with each server's storage and the daemon server with the above-the-bar storage it owns and controls. we're going to illustrate the local com function in the somewhat conceptual way you see on the chart here. The solid orange bar represents the cross-memory transfer between server address spaces. The dotted orange line represents the daemon's maintaining of transfer control blocks in the storage above the bar. So what's the best way to make local com accessible to address spaces on the LPAR? You create an external interface to local com, and you make it bidirectional. Let's refine the picture a bit and set the stage for what will be discussed in the remainder of this video series. We start with the same LPAR representation. We add the two application servers and the daemon server. We remove the storage clouds and show the local com mechanism as the solid orange bar between app servers with the dotted line showing daemon control. Here are the questions we must answer. The first question is how WOLA is delivered and priced. Then we must ask what external address spaces are supported with WOLA, and how the WOLA interface is accessed, and whether WOLA is transparent to the applications, and if not, then to what degree must the application know about WOLA, and then what the programming requirements are, and then the issues of security and transactionality. Let's now focus on the details of delivery, pricing, and installation. It is delivered as part of the maintenance stream for WebSphere Application Server version 7. It was first made available with the 7.0.0.4 maintenance release. The function was updated in the recent 7.0.0.12 release. There is no charge for WOLA. It is part of the cost of the WAS ZOS product itself. Enabling the WOLA support in a cell environment is a relatively simple process that is well documented in the WP101490 tech doc and the Product Info Center. We will not cover installation and enablement in this video series. The focus of this video presentation series is on using the WOLA function. That is where we will spend our time. The supported external address spaces are as shown on this chart. This is as of the 7.0.0.12 maintenance release. The first supported external address space is batch. Access to Java EJB assets from batch was one of the early customer requirements that launched the WOLA development process. Another external address space is Unix Systems Services Processes. In many ways, this is the same as batch. WOLA also supports Airline Control System, or ALCS. ALCS is a high-performance transaction subsystem similar to TPF. There is an ALCS brochure under the WP101490 tech doc. CICS and IMS. Our focus will be on the three highlighted by the blue bars. There are three fundamental concepts we wish to establish early on. We will refer to these throughout the rest of the video series when we explore the details. The first key concept is that before any use of WOLA can take place, the external address space must first register into the WASI server. There are several different ways registration may take place, as you will see. The act of registration is always initiated by the external address space. Registration is what signals to the daemon to construct the transfer control blocks and to ready the connection pool. The registration carries with it a name. This will become important when we explore the use of the native APIs and the Java programming considerations. The next key concept is that once registration has taken place, the exchange of messages must be initiated by one side or the other. If the Java program in WASI initiates, then it's known as an outbound call. If the external address space initiates, then it's known as an inbound call. When we speak of inbound and outbound, we are always viewing that from the perspective of WebSphere Application Server. Which side initiates will prove important in understanding the native APIs, the CICS and IMS support, and the Java programming considerations. The last key concept is that WOLA itself is a very low-level exchange mechanism and is really a byte array pipe. WOLA itself does not concern itself with issues of code pages or data layout. However, the application layers on each side do care about those things, so some degree of coordination must be made at the application level to ensure one side's message can be properly understood by its partner on the other side. Let's now explore the programming access to WOLA. There are two sides to consider, the WebSphere application server Java side and the external address space non-Java side. Between those two is the WOLA exchange mechanism. From the WASI side, there are two components, a set of low-level functionality that provides the bridge from Java down to native execution, and a higher-level JCA adapter that implements the common client interface. For batch programs, access to WOLA is provided through a set of native API modules. The support in CICS is provided with a task-related user exit, or TRUE. In the CICS section of this video series, we explore in more detail the manner in which your CICS programs may be shielded from any knowledge of WOLA. The IMS support has several elements which we will explore in more detail in that section of this video series. IMS programs may be shielded from WOLA by using the WOLA over OTMA, or they may write to the native APIs provided by WOLA. There are many details left unsaid at this point. We have set the stage, but not explored in much depth this thing called WOLA. We will see much more as we unfold the remaining sections of this video series.